So, right, so introduction to version control system. Version control system basically is known as source control. You can call it either version control or source control. It's a practice in software development that, excuse me, it's a practice in software development that we use to track and manage changes in software in a code base. When I mean code base, I mean your code that you've written, your HTML code, your CSS code, your Python code, your JavaScript code, any code at all, so long as it's a code, it's a program, basically. Version control helps you to manage different versions of your code at different time interval. There are tools actually that helps team. Most of the time, software is not developed by one person. If you work in a company, you find yourself developing softwares by different persons. So you can have 20 developers, 30 developers working on one project, different arm of the project. Some persons might be working on the front page, some people are working on the footer, some people are working on the back end. It's one project too, but they are divided into different branches, and you have various team of software developers working on different arms of this software or website or web software, whatever you want to call it. Now, this version control foster teamwork. It makes people to work faster. It helps collaboration. People can be at anywhere and work. It is even the major reason why remote work is easier and coordinated among team members. Okay, that's basic definition of what version control is. Now, you might ask before what, because software engineering is dated back to even the 90s. It's not now that they started. You might have before, when what was they using? What were they using before now? When something like version control has always been in existence. Even the very minute software engineering started, it has always been in existence. Just that in a different phase, there are different ways. Different generations of software engineers have different ways they manage their code. Do you understand? And that's what we're going to be seeing them in these types of version control system we're going to be talking about. We have types of version control system. We have local version control system. We have centralized version control system, and then we have distributed. Okay, just take note of that. Then, what is local version control system? It is one of the simplest forms. It is one of the simplest form of version control system, and it has a database that keep all the changes you make to a file. You understand? So it is basically known as a revision control system or RCS, as the case may be. It's one of the most common version control tools. What it does, how it works, is that it keeps patches, or let me say sets of different changes you made in different file formats. So that at the end of the day, it can be able to recreate those changes you made into one file and then give you a bundled version of every changes you made. Now let me give you an example. For those of us who doesn't know what Git is all about, those who have used Git, like Victor and Friday, they will understand. But for those of you who don't understand, let me give you an instance. It's just like when you have an Excel sheet, maybe your lecturer in your school or your teacher, whoever, have a list of students. But in that list of students, he doesn't have all your details, right? He only knows we are 30 students in a class, and the teacher knows only about three. Of let me say, okay, 30 students, the teacher knows only about 10 of you. Then 20, he doesn't know their names, but 10, he has their names offhand and their reg number. He decides to create an Excel sheet or a Word document online on a Google Sheet that has name and reg number. He writes the names of the ones he has offhand and their reg number, and then push the link on your WhatsApp group. And I say, everybody, please, so if you go to this link, if your name is not on this link, please enter your name. Do you understand? Some of us must have this type of experience. Now, what that does is that not everybody will see that file, that link as at when the lecturer sent it. But anytime anybody sees that file, that link, they will click on it and go to that sheet online. And then when you go, you will see the names of, maybe probably when you enter, you will see maybe 20 names you have written. Somebody else will go to that same link. The person will see that the names is now 23. Somebody else will go. You might even be typing. Immediately you are done typing, you are seeing the number have already increased to 34. These are the, it's like a sheet. The sheet is tracking the changes everybody is making as different time interval. That is the same way this local version control system work. But this time around is a software tool that is running the changes by itself. You are not the one in charge of your changes. All you just need to do is to let it know that you've made a change. It is just going to save those changes that you are making. It's changing it at different time interval. Is packing it, just keeping track of them so that when it is needed by any other person who is working on you on that same project, it can recreate the full version of those changes in one file and then give it to the person. Believe that makes sense. So that's for local version control system. These are like the earliest version, how it was used back in the days. Then we have what we call centralized version control system. The centralized version control system contains just one, what we call one global repository. A repository is like a storehouse or a warehouse that receives every inventory that is coming in. When load is coming, warehouse can contain goods of different traders. You can have 10 traders using one warehouse. Some Mr. Obi can be a importer of tomatoes. Mr. B will have one column in the warehouse where he just packs his tomatoes, abi. And Mazi Nduka will have his own column where he packs maybe Maggi, he imports Maggi, they stack his carton of Maggi in his own column. So you can have, but it's just a central warehouse where different people store their goods, right? That's the same how version, centralized version control system works. It's just one global repo, but we have plenty users that are using that are connected to that central repo. Now, how it works is that every user need to commit like his changes so that it will reflect, you understand, on his own changes. When you are done working on your own branch, your own system locally, you can then update the global database, the store warehouse. It will now receive your updates and keep the changes. Another person will be done with their own changes. They will push, but you don't push if you are not done, right? You understand? The thing just updates. Now, but at a point, there's always this worked. This decentralized social system was working because it gives team access to like having a centralized system where everybody can work and push their updates, and at the end of the day, it will be sorted out by the head or lead engineer. But at some point, this wasn't working. This system wasn't working because sometimes someone might make a change and I make a change. Let me say we are three working on a project and I make a change, and then this other person will make a change, this other person will make a change. And when we push, if we don't communicate with each other, we won't actually know. Our changes is tracked locally, but when we now push, there might be conflict. Someone might mistakenly worked on my feature, and I'm working on the same feature. So we might have duplicate entries in the global store, right? But now there's another one called, sorry, another important thing you should note on this centralized version control system is that there are two key things that are required to make your changes visible to others to see, which are you commit your changes, and those your what's it called, team members update. Once you push globally, they just update and then they catches your own updates alongside with what. So it's more like there's a list, global list. Immediately you make your own changes, it updates the one online, and then them will update their own repo. It pulls what is online for them, and their own is completed, right? But now you see a little bit difference in distributed version control system. Now, the centralized version control system has its own ups and downs, and that gave birth to distributed version control system. When they say something distributed, it's just like blockchain. Like someone when something is decentralized, well, blockchain is a bit complex. Let's not even bring it into this system here. So let me just read what I have on the slide. It said distributed version control system contain multiple repositories. Each user has their own repo and working copy. Just committing your changes will not give others access to your code or to your changes. You understand? That's where the difference comes in now. This is because commit will reflect those changes in your local repository, your local files on your system. You need to push them in order to make them visible on the central repository. You understand? Similarly, when you update, you do not get other people's changes unless you have first pulled those changes into your own repository. Now, these two might look a bit confusing, but I will explain. They say to make changes visible to others, four things are required. You have to commit, you have to push, then they will pull, and then they will update. Now, let me explain. This is even the method of distributed version. This distributed version control system is the one that is currently being used now. It's more popular. That is what people use these days. And then how it works is that there are three people working in a repo now. One person makes a change. As you are working, a local repository is created on your system, and that repository tracks everything that you are doing, just like the way the local version control system works earlier. It's just keep tracks of your changes. You understand? You can create multiple branches inside your own repo locally. You'll be doing everything you need to do locally. Nobody needs to see what you're doing. Nobody have access to what you're doing. But whenever you feel like there is time, it's time for you to push what you have to the central database, which everybody have access to. When you now push the work, that is when it will now be visible to others. But it does not affect what other people are doing. Do you understand? All those people, when they are now building their own, they can now pull your code down to their repo. Now, if there's mistake of duplicate entry, he went and worked on a place where they are working. They will, that because it's distributed, it will their own will tell them that what they have is different from what you have. So they have to make some fixes in order to correct those changes that are conflicting, right? So that's how the distributed system works. So basically, it is distributed. Everybody have access to their own separate. But centralized is that you don't have your separate repo. You are working online, but immediately you are done, you just push what you have online. But this one, you can work online. You can you sorry, you are your work is self-contained. It is just yours. So you only choose when you want it to be online. You can even have multiple branches, but still on your locals. Even online, you can still personalize it when it is online, but it is not sent to the central server only when you think you are done. And there is no conflict. Even when there is conflict, it has an easier method of resolving conflicts. All right. Then we have why did we even need version control in the first place? Now, these are the reasons. The reason why we need version controls are so that multiple people can work simultaneously on a single project. Everyone works on and edits on their own copy of the project. So with version control system, you have a copy of that project on your own. Whatever you are doing does not affect the main project. Even when you make a push save, it doesn't still affect the main project unless when the project owner or the project manager decide that he wants it to affect it. That is when it affects it, and it can easily be reverted. That's the beauty of version control system, right? And it is up to them when they wish to share the changes they made to them to the rest of the team. It also enables one person to use multiple computers to work on a project. Yes, very important. It is valuable even if you are working by yourself. You remember that day we were having live classes like this, and my laptop went up, and I tried to push the work online. It is because the work was not on a repo. I've not even created any, even both locally and online. I did not create anyone. So that was why. But had it been that work was online, what immediately the laptop went off, what I could have done is just go to my other laptop and pull the code on that laptop, and I'll continue from where I stopped. All right. So that is one of the benefits. It integrates the work that is done simultaneously by different members of the team. In some rare cases, when conflicting edits are made by two people to the same line of a file, then human assistance is required by the version control system in deciding what should be done. I mentioned this earlier. Version control provides access to historical version of a project. This is insurance against computer crashes or data loss. If any mistake is made, you can easily roll back to a previous version. It is also possible to undo specific edits that too without that too, without losing the work done in the meanwhile. What this means is that you can be working and you've done a massive changes and you feel like this thing is not giving you the idea or is not giving the design you want. You can actually roll back to the previous version, to the default state. It helps you to keep track of different states of a project, so you can roll back at any time. It can easily be known that you can even have a log of a history of every single changes that have been made on a software. And with this is how software versions are made. We have version 1, version 1.0, 1.00, 1.2, 1.3, and this is how they are formed because every version has a software patch. What software patches means there are changes, there are fixes that have been done, right? So that's that for purpose of VCS. And we have examples of different version control system. We have the Git, which is the most popular. Git is the most popular option and has become the synonymous with source code management, which can also mean version control systems. Git is an open source distributed system that is used for software projects of any size, making it a popular option for startups, enterprise, and everything in between. Excuse me. We have another one called Subversion. Subversion is another type of a version control system, but it makes use of the second type, which is centralized version control system. This was used back in the 90s and early 2000s before Git was popular. People started adopting it. It was the owner of Linux operating system that developed Git. His name is, I think, yeah, Linus Torvalds. So this system keeps all of a project file on a single code line, making it impossible to branch. So it's easy to scale for large projects. It is simple to learn and features folders security measure. So access to subfolders can be restricted. This one is good, but it's only widely adopted when you have massive projects. But whatever it is a subversion control system can do for you, Git can do better. Then we have Mercury. Mercury is also a distributed. This one is not a centralized, so it's a distributed version control system. Offers simple branching and merging capability. So what that means is that it just helps you to just branch, like create different branches from a single project, and then you can merge those branches together, and you can create different versions of those branches. The system enables rapid scaling and collaborative development with an intuitive interface. The flexible command line interface enables users to begin using the system immediately. Right. So these are one of the most popular, um, the three most popular version control systems that we have. But one that is widely used by company in this 21st century is Git. We have a question here. So what is Git and GitHub? I forgot to put a question mark here. Okay. Say Git is an open source distributed version control system used to track changes in software development. While GitHub is a web-based hosting service for Git repositories. Note, you can use Git without GitHub, but you cannot use GitHub without Git. Let me explain. Git is the tool, a software to use to track software development, the changes made in your code, right? Then GitHub is like a hosting website where you just bundle your website to host. If you have ever hosted any website before, but if you have not, the reason why you're able to access most websites online is because they are hosted online. They are hosted on the World Wide Web, right? So GitHub is a hosting platform, is a website that helps people to host website. But this time, instead of hosting website now, what is now hosting is Git repositories. Git repositories is a store that houses your Git. So when you are done working locally and you want to create a central server for that your project, do you understand? You can now push it to GitHub, and GitHub is free to some extent, right? Okay, because they have enterprise version, they have student version, they have the free version, and all that and all that. All right. So why this statement they say you can use Git without GitHub, but you cannot use GitHub without Git? What it means is that you can use Git on your laptop and track your code and changes so that, because one beautiful thing about Git is that even if your hard drive, do they say if your hard drive crashes, you can still recover your Git files. But I've not experienced that But what I do know that I've experienced is I've been working on a project and I have a very deadline and I've completed my deadline. After before the day I would demo the project, this project I knew Git as of then, but I wasn't using Git for that project. Immediately, I just deleted a file. I don't know how it happened on my Windows operating system as at that time. I think that was 2019 or 2020. Windows operating system. Everything. Maybe I accepted that delete of VS Code. Everything wiped out. The only thing that was remaining was my index.php file. Everything went off. I became mad. And then I had exams to write. I was so mad. I have to call the person I was working for, explaining what happened. The person was like, how can you allow this mistake to happen and all that and all that. He said that the only option that I have to give him, he can only give me only 1 week extra. Something I've used about 3 weeks to work on. Now you're giving me 1 week extra to build something I built in 3 weeks again. I accepted the challenge. And this time around, maybe person tell me to use Git. So, but the truth is that file, those files that was deleted, had it been I had Git, I could actually track those files back. Funny enough, when I deleted those files, I didn't see it in my recycle bin. I checked and checked. I even have to find tools that can help me to reverse my hard disk to a certain state. It was not possible again. But if I had used Git, I could have retrieved those files. Because I also worked in a company where, for some reasons, I don't know what happened, I lost almost majority of the recent module I built on that and it's a very big application. There's a module I was working on. I lost it. But luckily for me, I was using Git, so I was able to recover those files. And funny enough, those files that was lost, there was no trace of them in my recycle bin. But with the help of Git, I was able to trace them back. Right? So we see how important and powerful Git is. All right. So I'll be showing us. We'll be going over to the code. I'll be showing you just quick example how to create a Git uh, repo on your local, how to create a Git profile on GitHub, and then how to push your code there. These are the three things we're going to do. So please hang on. The last slide says four important Git command. We will use it and you will see. And these are basically the command you are going to run. We have git init. This git init initializes your git. We have git add full stop. This full stop means add all. You can actually select a specific file you want to add. It's not a must you add all. But me, in order not to miss out on anything, I like using add, and it's most popular among developers. Nobody wants to add unless there's a reason for you to specify the file name, and you have to be sure you are on the right folder path, else you won't track it. So, but I like using git add all so that it will just add everything, even if it's just one command that I added, it can just track it for me. And then git commit is more like a description message you are giving to. Once you do a git add all, you are saving every changes. You are preparing every changes to be staged and saved for you. Do you understand? When you now use git commit, this dash m helps you to add a message. Though there are some other commands that you can do without using, but it's important you put a git commit message. This message will help you in later time if you mistakenly lost your code. With this message, you can be able to remember at what point what was your last commit, and then the last commit, how did you, what was your last commit, and then you can use that last commit to retrieve the changes from that last commit down or from that last commit up. You understand? So it's very important you put your git commit message. So it helps you. And once you run this command, it just bundles the message and then wrap it up with the git with the files that are already staged and then save it for you locally. Unless when you've already connected your code to a repo online on GitHub, that is when you can now do a git push and it will now save your changes online. And it's good to push your changes online so that once it's online, you can access it anywhere from any world. But if it's on locally, you cannot access it. The only benefit locally is that you can't lose it for any reason. Even if you delete the file, you can still recover them. I believe that makes sense. So we'll be going over our code. I already have a Git repo for this project, so I am not going to do this. I'm going to create a new project. I'm going to create a new project here. And I'm going to create just two files, and I'm going to create a repo for that, and then just to show us example, and then we can move forward. All right. Okay. So um, what else here? Okay. So let's go back to VS Code. Or here we open a folder. Where's that folder? So we open our folder. We're not going to create a file called index.html. Then we're going to just this file. And then we're going to create a document. It's test H1 practicing how to use Git. That's just it. And then let's open our terminal from VS Code. If we open our terminal, I believe you all can see my screen. Hope I'm not talking to myself. Hello guys, can you all see my screen? Okay, all right. Let's move forward. Okay, so ah, going to my file recorder. See me. Let this thing not stop my recording. I hope it doesn't stop my recording. Let me check, guys. Hold on. This recording software, I built it myself, even though we are still working on it. Okay, we are still recording. Excuse me. Uh, we're still recording. Thank God it didn't go off. All right, so this is our Git, our full project. We don't have any repo attached to it. Now, for you to use Git, you must first of all download Git. Just go to Google and say download Git. If you are using Windows, it will detect. I believe most of us are using Windows. Is anyone using Mac? If you are using Mac or Linux, can I see your hand up? Okay, it's like nobody is using anything other than Windows. So you can download for Windows, you can download for Mac, you can download for Linux. It's just git-scm.com/downloads. All right, so this is where you download it. Let me drop this link here, or I'll drop it on Telegram later. But let me drop it here so that any of you can copy it and put it on Telegram. It's fine. That will make my work a bit easier. So here, you can come here and you download for Windows Git. You can then when you click on it, it asks you if in Zoom, so you will see. If you are using 32-bit system, you download. If you are using 64-bit system, you click on it. You understand? So me, I'm using 64-bit, so I'll just click on download here. And once it's done downloading, once it's done downloading, you install. And once you are done install, just keep clicking on next. It doesn't add anything. I have this in my system already, so I don't need to download it. But it's quite straightforward. You just click next, next, now just the way you do normal installation on Windows, and then you are done downloading. Then once you are done with that, for some old Windows, me, I'm using Windows 11. If you're using Windows 10, you can just refresh. And then if you're using Windows 11, you don't need to restart your system. But if you're using from Windows 10 down, you need to restart your system so that you can be able to run the git command. Sometimes when you are done installing it, it will not, if you type the git command, if you are done installing, for you to test if it worked, You can come to your terminal, come to your terminal, and then type git. So once it brings out this call this command, you go. If it throws error, it might say this command is not recognized or something. Know that it has not added to your environmental path in your system. So you need to restart for you to catch the new installed software. So, or you can do git minus v to give you the version of the git you're using. This is what it will do to you. It will give you. So just take note after installation. This will tell you whether you installed it correctly or not. That's fine. All right. So after this, let's go back to our code that we want to track with Git. When you come here, for us to track, remember I said you need to initialize the Git first. Initialize it means you want to tell Git, please, I want everything in this folder to be preserved for me by Git. That's why we are using the command Git. So once you do that, Git will automatically prepare an environment and waiting for you to now push those files to it. So we're going to do Git init here. Git enter. Remember, we need to be in your project folder. So the easiest way and the best way is just open the folder of your working project, your project folder, sorry, open it in your VS Code. That way, if you just click on terminal and open terminal, VS Code will automatically open a terminal that is already within your project folder. Do you understand? So, as you can see, immediately I did git init. Immediately I did git init. It just changed something. Something was added here. Master, it means something it has prepared something. I did it again. It said reinitializing existing Git repo. That means it's doing the reinitialization again. But once you've done it once, you don't need to do it again. Then, for some of you, please let me highlight this. You might not see this colored outline here on your own. The reason because by default, the VS Code make use of the Windows PowerShell. So if you want this to, when you install Git comes by default with what we call Git Bash. It's a Linux-based terminal system. So it's so that it makes your terminal looks final like this. So if you want to use the Git Bash, as you can see here, you can come here and click on this thing. You can then see this is the Git Bash that I'm currently using. But you can change it by clicking on this drop down button here after the plus sign. Click on it. You now see different terminal system you have on your system. You see the Git Bash. I made it my default, but by default on your own, if you've never installed Git, if this is your first time of installing Git, what you will see on your VS Code terminal is PowerShell. It will be like this. It will not be colored. By default, this is what so you can change it to start using Git by clicking on Git. You will see Git Bash. Once you see Git Bash, you click on it. Once you click on it, and you can also set it as default. Me, I set my own as default. See, select default profile. If you click on default profile, it will give you a drop down of all the terminal system. You have the Windows PowerShell, you have the PowerShell, you have the JavaScript debug terminal, you have the command prompts, which is the CMD, then you have the Git Bash. But I like using Git Bash. That's why I selected it as my default profile. And that's why everything you are seeing here is Git, 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 Git. I believe that made sense. All right. So here we've initialized our Git. Now for us to catch all the files, you can have as many files as you want. So long as you're in the project folder, you are okay. Once Git init will catch everything. Then we'll do Git add. We can do, because we have only one file here, I can do git add index.html. Make sure you add the extension that's added. And immediately I did that, you see the color of the HTML have changed. You understand? But don't rely on this color because it's because of the theme, and I have some extensions installed. But definitely once you've done that, so long as there's no error, it means it has added it. Assuming I added another page here called about.html. I add another thing called you see it is unstaged. U means on but it's still green. It's still seen by Git, but Git has not catch it. So instead of me doing git add about.html, I might not have all the You might do some npm install, like if you're using JavaScript, you might install some packages you don't even know their names, and there are some hidden files. So to be on the safe side, you just do git add full stop. That will add everything. Do you understand? So as you see, the about has been added. It has changed to a unit that has been prepared for staging. Now we want to push, we want to save. Everything has been prepared, the file has been tracked, every changes we've made have been tracked. Assuming we add something in this about.html now, what this one about change, about page, sorry. So I've made changes, it's not tracked. As you see, the color have changed. Git is now recognizing that I made a change on this file and it is not yet tracked. So I need to track it, even though I've not saved it too, because when you do git commit, it means you are saving everything. I've not saved it, so it's still showing me something has changed, so I need to track it. So I can now do git add again, track everything. And once I do that, it has been tracked, as you can see. I can now do git commit to save my changes, and I'll give it a name. I'll say first commit. You can give it anything. I can say just added about page, just added about page, anything, but I want to say first commit. And make sure that your commit message is wrapped up in quotes, whether single quotes or double quotes. Remember, git commit dash m space, then your quote, you type in your messages, you end it with a quote, whether single or double quotes. When I hit enter, the files have been created in Git and it has been stored locally on your system. There's something else I want to show you about Git. You see this folder we created now. The reason why you are seeing, by default, if you do not set your view to show hidden files in your system, you won't see this Git folder. It's usually hidden. You understand? But I set my own view so that I can see hidden folders. That's the reason why I am seeing the, what's it called? See hidden item. I take it to scene, so I'm seeing it. That's why you are able to see the Git folder. But normally, if you're not seeing it, you can just set your views, go to your views and check hidden and tick it. You will start seeing it. So this is the folder where Git is going to be tracking all your changes. And please, you don't need to touch here. Please don't go there. I'm just showing you for showing sake, but you shouldn't go there. Now, we've tracked all our changes and we've saved it. Now, going forward, any small changes we make, we can always use these commands: git add and git commit. Git add will track it, git commit will save it, git add will track it, git commit will save it. Just continuously, so long as you've initialization is just once. You don't do it all the time, it's just once. What you now use to be tracking your changes and saving is git add or and git commit. That's git add full stop, then git commit dash m, your message you save. But now we want to push this code to GitHub. Let's move over to GitHub.